Yes, sir.
Okay,
Yes,
fine.
sir.
Okay.
Yes,
So,
sir.
uh, what we had discussed yesterday was actually what is data mining and what are the steps involved in data mining. Today, we'll discuss the first category of data mining algorithm, which is known as association rules mining. Okay. Uh, you can see that actually the very first point is actually market basket analysis. Okay, I think hopefully most of you are aware of this market basket analysis. Uh, you are aware of?
So it will be better if you explain us once.
Okay. See, I think all of us experienced this, say, Big Bazaar or Pantaloon or other sort of similar retail markets, where actually what you do is actually you go with some sort of basket and you pick items going through in like maybe in one floor or multiple floors, and when your list is exhausted then you go to the cash counter or a billing counter, and then you can actually purchase all those items which you have kept in your basket. So what is happening out here is that it is actually creating one transaction ID for you for each of the customer, and then there is a list of items, their prices, and obviously overall the cost of your purchase will be there. Now the question is that normally what we do is that we go and we purchase and we come back, and we never thought of that uh, what actually be done in terms of analysis of your basket. Normally, this market is actually assessing or analyzing your basket also by time to time, like it may be in 1 week or it may be day wise, it may be month wise, other things. Reason is very simple, that they want to track the trends of the customers, and obviously trends of the customers may vary depending upon location, depending on region.
Excuse me, sir.
Yeah.
Sir, your voice is coming very low. It seems your mic is a bit far.
uh, Now it is okay.
Yes, sir. But
Just a minute, just a minute. I'm just connecting with a Bluetooth device. Probably it is working. Okay. Am I audible now?
yes, sir. Better.
Voice is not proper?
So
No,
you
sir.
are
Now it's
audible.
fine.
So it's fine now.
It's fine now, no?
Yes,
Yes, sir.
sir.
Okay. Believing that everything is, I think am I audible to all? Uh, so I'm just moving. So what Raj,
Yes, sir.
just instruct your classmates
Yes, sir.
that once the class will start, nobody is will be allowed to join. Okay, now
Okay,
onwards.
sir. Okay,
Okay,
sir.
so just join beforehand, maybe
Yes, sir.
5 minutes before itself. Okay,
Yes, sir.
so just be careful with that. Okay, I'm just restarting my thing. So today we'll be discussing the association rule mining, which is one category of data mining algorithms, where actually we look for association rules. The first point itself says it's actually market basket analysis, and this market basket analysis is a very famous example. Certainly we all are experiencing the purchasing of this in Big Bazaar or Pantaloon or Walmart, whatever, like such markets, retail markets are allowing you to roam around with basket and you pick the items by own, and then certainly you go for billings and you come out from that market with all exhausting your list. What actually, like, we never thought of that, whether it will be this your basket should be analyzed or not. But the fact is that your basket is actually analyzed by the market or the officials involved in the market. Certainly, there must be some reason for that also. So what you do is that actually they try to capture the trends of the customers. It may be in terms of purchasing habit, in terms of purchasing capacity, in terms of purchasing pattern. Obviously, capturing such pattern may actually help you in so many ways. Like help you, if I say help you means it is helping the bazaar. Say maybe the big bazaar might be interested to know about the purchasing habits, purchasing pattern of the customers, maybe in Jharkhand region, maybe in Uttar Pradesh region and all, because that will help them for a future plan also, like in terms of demands, in terms of inventory, in terms of actually trying to enhance the profit also. So there are so many things which comes in picture, and it is very much important also for the market. So the question is how this actually basket will be analyzed. So what we are doing is that you have a list of items. You go to that market. You just pick the items, whatever is available in the market, and then you take the bill and you come out. And all. Now the question is that there will be thousands of the customers which will be actually visiting the market maybe per day, and if you look on per month, it may go up to more thousands than if you look for say 3 months purchase, then for 6 month or 1 year purchase, then it may go up to lakhs and all, and maybe more also. So what we do is that we store all these data into a transaction database, where actually certainly it is not required that your name, your information should be there, rather than I'm treating the market is treating you as one transaction ID. And normally, if you see the bill, you'll find that there is a transaction ID, date, and then there are so many informations like GST and others are there, and then whatever items you have purchased, respective prices, and overall total cost will be there, which you have paid on. So what the Big Bazaar does is actually they actually collect all such informations and treating each of the customer as one transactions. Then there may be multiple rows, maybe thousands or lakhs of the rows, and in that there is a transaction ID, and then there are items purchased. So there are two things we try to take. Say you can see that. So what we can do is it looks like this. You can see that it will be of 2 column, where actually we have transaction ID and then items. So maybe CT101 if I write, and then maybe A, C, E, Z, something like I can write, and similarly for T102 and so on. So there we are just trying to capture the items purchased by the individual customers, and then we try to analyze this particular data. This particular you can say that if you look on this particular is particular information where we kept is known as transactional database. Okay, that we do. The question is, why do I analyze this, then certainly as far as they are concerned is that certainly it may regularize their demands, it may regularize their inventory, it may regularize their self-management also. Like I can tell you one example, like depending upon a reason-based pattern, then certainly I can rearrange my demands and rearrange my inventory. Reason, like suppose in some reason some item say C or E is mostly purchased by the customers, so I can actually increase the demand of CE. Accordingly, I can put demand to the manufacturing units that I need more CE compared to A or Z. And obviously, this will actually be used for efficient management of the inventory and demand. Next comes that in terms of, you can say when you try to increase the profit level, then you can make use of these patterns also. Like suppose 100 customer visited the particular retail market, and out of 100, 90% of the customers have purchased say C and E. Okay, so that means I have a support of 90%. Out of 100, 90 customers has gone for that. So obviously in that case what will happen is that I can say that okay fine, this C and E is having a strong association. I can say okay, C is I can say this is butter and this is bread. I can write like this. So is this butter and bread will have a strong association based on the purchase pattern of the customers. Now, this I got from this particular transaction database. Now, how do I make use of this? Certainly, you can see that what I am saying is that can be used for self-management also. That may be used for deciding whether an item should be put on sale. That can be always be used for maybe I do not know, like what we call it as that there is a positive marketing and there is negative marketing in our case. I think you people can always visualize that part. What actually we mean negative marketing and positive marketing is that if I have to rearrange the shelf, then I'll be looking for this pattern that okay fine, butter is having a strong association with bread. Then what I'll do is that I'll put bread and butter at one place. What will happen in that case? Certainly a customer may come with only of demand of butter. That means that the list he is having is only having the demand of butter from his house. So he may go for butter, but the moment he sees or he or she sees that okay, there is bread also, then he may or she may go for bread also, believing that this might be useful. So what it actually happening is, even if the butter was only the item in his or her list, but still he is picking bread out there. So this is actually, you can say it's an enhance or increase in terms of profit if I look on. Okay, this is one thing I can do. So by putting, and it is not necessary that this association only with the one item become one item. This association may be a set of items to set of items as well. This association may be with the one item to multiple items. This association may be with set of items to one item. So cardinality may be different. It may be one to one, it may be one to many, it may be many to one, it may be many to many as well. Depending upon what sort of pattern you are extracting from the transaction database. Now, there is what we call it as, probably you can define the better word, that is known as negative marketing. What is negative marketing is, it actually results in increase in profit also. What Big Bazaar will do that believing that bread and butter will mostly purchased by almost all the customer, maybe 90% customers. So they put bread and butter into two corners of the floor. That might be in the one corner is butter and the another corner is bread. So what will happen in that case is that certainly you will go for purchasing this particular bread and butter. Then you pick the butter first, and then suddenly you start searching for bread, and some like salesman can say, okay, sir, bread is in that side. So you start walking, and in between you are looking on the items which is actually kept in the shelf. There may be some attractive offers on those shelves, says this is free with this that is free with that. And what happens actually in that case, just having bread and butter, you are just looking on some other items also in between, and then looking on some offers, you start picking even if that those items are not in your list. So that actually results in increase in the profit in terms of such market. So that though it is not a it may not be treated as positive sort of things, but still it works at least for big bazaar. And certainly customers are actually getting more items. Normally I think all of us are going in such market, and normally what happens is that we went in with some say 10 items of list, and we come out with maybe 25 items. That is what actually those markets are looking for. So such applications are possible when you look for association rule mining. So, so we'll be talking about how to extract such patterns from those database and how to use it for decision making. So that is what we'll be dealing with. Okay. Uh, Now, so what we have is that other interesting applications for uh, association rule mining is that I can go for some interesting application like document analysis also, where actually I'll be looking for basket is actually documents will be treated as baskets, whereas words will be treated as items. Then obviously I'm interested to look on what are the words which are appearing frequently together in documents may represent some phrase or link concepts, and it can be used for intelligence gathering or some sort of decision making also. Normally we do it for social network analysis. We always look for association of words in terms of summarizations, in terms of inference, in terms of recommendations. So there are other applications also, not only in such market also there are applications, and this association rules mining is very much applicable in different domain areas also. Say document analysis, then there are areas like in bioinformatics when we talk about some sequencing or protein gene sort of predictions. It is highly useful in those areas also. Even it is useful for medical data also, where actually we can analyze the patients within the ICU uh, and trying to figure out that how one particular patient is actually very close to other patients as well, and how a set of like you can say the patients are actually associated with the set of medicines. By virtue of that I can like the officials of the hospitals can figure out the moment a patient comes, and if it is highly associated with other patients, then I can figure out that what are the things to be done for that patients as well in a very speedy manner. So that is what we do it. Okay. So what are the things involved? Certainly, if I take the example of the market basket analysis, purchasing of one product when another product is purchased represents an association rule. So used mainly in retail stores to assist in marketing. It actually assists in self-management also, and it is also very good and very decisive in case of inventory control also. Obviously, other areas like telecom networks, traffic analysis, document analysis, bioinformatics, computational chemistry, in all such fields it is applicable. What are the components in such analysis is that you actually require some transactional database, and then certainly we what we call it as that item sets. Certainly in case of market basket analysis, each customer will be treated as one row, and there will be two columns where actually one column will be for transaction ID and another column will be for item sets. And then I'm looking for frequent or large item sets. When I say frequent or large item sets, that means I'm looking for a set of items whose supports are high. Supports, if I say, that means if I say that A and C are having high support, that means if I fix say 90%, then in entire database, the frequency of AC will be in more than 90% of the records. So that we are looking for. Certainly, as I told you, that support is required to be there, and obviously to find out the relevant association rules, we require support and confidence together. Support is actually the occurrence of set of items together, whereas confidence is actually a conditional probability of, like this actually talks about that you can say that you can write like say probability that A item is occurring, then what is the probability that C will occur. Okay, so this actually gives you the confidence level of that particular association between A and C. So that is what we do it. What are the types of association rules actually we look for? Normally, what we do is that we have the first type is Boolean and quantitative association rules. So just I told you that bread and butter. So bread and butter, I think here I can write like this. This actually signifies that there is a strong association between bread and butter. And then obviously we look for presence or options of this particular rule. Then next, then you can see that this one, if I go for, then there is age, income, and then buys. So these are the components. These are dimensions, we call it. So this is multi-dimensional association rules, where actually 3 dimensions are there. 3 dimensions is 3 attributes or 3 features, you can say. So I'm looking for the person X whose age is between 30 to 39, then income is 42 to 48, and then there is association. In this case is you can say that this is association where actually you are saying that the person having age this, income this, is actually will go for buying a projection TV. So that actually, this is quantitative. Why I call it? Because I have defined the person age is between this. So I'm just quantifying the specification of the person in terms of age, in terms of income also. So this becomes a quantitative ARs. Whereas single and multi-dimensionals, certainly the second one is actually multi-dimensional, whereas the first one is actually a single dimension. So you can say that a person is buying bread may go for buying butter also. So this is single dimension, and the above one is the multi-dimensional. Now there is a possibility of single and multi-level ARs also. Single and multi-level ARs is actually that if I say that okay, there is butter having association with bread, so there is association at this level also. I can have types of butter and types of bread also. Say this is white bread and this is brown bread. So there are two types of bread, and this, sorry, I think I made a mistake. Butter is actually, you can say, full cream butter, and then there is some other butter like
It's unsalted and
unsalted,
unsalted.
yeah, unsalted butter, and then bread is white bread and then brown bread. Okay, so there is association between this, which is on first level, whereas I may be interested to have a association between this level also, the second level. I can say that I'll be interested to have a unsalted butter with white bread, or unsalted butter with brown bread. I may be interested to have full cream butter with uh, white bread, or I can be interested to have this also, because this will also help in all applications which I have talked about, self or self management or inventory and demand, because it may be the case in particular region people are actually looking for brown breads in place of white breads. Yeah, the people are maybe going for more full cream butter rather than unsalted butter and all. So
So
that actually
mostly
helps.
health conscious people like
Yeah. So that actually helps the market to actually rearrange their demands and inventory. So that happens. Okay. Then comes what is actually support and confidence. So say that we look for, and these two are actually user defined. User defined means if you are analyzing it, then and if you are analyzing it for big bazaar, then big bazaar, and you can decide what confidence and what support you are looking for. Because as I told you yesterday in the introduction part, that the support and confidence may vary depending upon the nature of the items, because I cannot have similar support for TV, fridge, and microwaves, such type of high cost items, compared to when I talk about bread and butter, or I talk about cereals, or I talk about some other clothes and all. So depending upon what category of items and what domain you are working for, the support and confidence should be decided. So what actually confidence says, that suppose I'm looking for association where actually I'm looking for that one and two, these are items combined together. If customer goes for, then there is a likely to purchase these three also, is having 90% confidence. So what it says is that when a customer bought one and two, then in 90% of cases the customer may also go for three. This is what confidence we call it. And this you can always uh, can put it into this form also, like, okay, fine, one and two, and what is the probability of this? Okay, so given one and two, what is the probability of three? And this can be always be, you can say, I can always figure out from the transfer data also. Like suppose if I say I have say 101 and 102, and I say that 1 2, then 1 3 4, then I can say that if I go for like, let us go for support first. The rule must have some minimum user side support, where actually you are looking for that 1 and 2 have a association with 3, should hold a some minimum percentage of transactions to have business value. Okay, what does it mean is that you have to find out that what are the percentage of occurrence of this 1 2 3 together. So in this case, if you find, then it is actually 1 2 3 is having a 0% support, because 1 2 and 3 is not appearing in any of the transaction. So if I add this 3 here, then obviously I can say that my support is 50%, because 1 2 3 together is appearing in one transaction. So out of 2, it is 50% occurrence is there. So my support is 50%, I can say. Now, what is actually the confidence we look for? So confidence says that I'm just looking for this given 1 and 2. So 1 and 2 is here. Now 1 and 2 is in this transaction also, but in other transaction 1 and 2 is not there. So 1 and 2 is occurring in one transaction only. Now what is the probability that 3 will also occur? So 1 and 2 and 3, it is occurring in one transaction. So out of one sample, the occurrence is 1. So that means your confidence is 100% in this case. Okay. So that is, if suppose if I add 2 here, and if I delete this 3, now the support is still 50% because 1, 2, 3 is occurring in one transaction only. But the moment we talk about confidence, then you can see that 1 and 2 is occurring in both. Now out of 2, it is actually 3 is actually occurring in one transaction only. So that means it is 1 by 2, and it is nothing but the confidence becomes 50% in this case. Okay, I think I hope I am clear. So this is what we talk about support and confidence for that. So what we require for any association rule mining is that you require one transaction database where actually transaction IDs are to be there, and then there are a list of items should be listed. So that is what transaction database. And then the list of items are known as item sets, and then we are actually interested to have frequent items depending upon what support you fix. And then once you get the pattern, then to accept the pattern, you look for confidence, that what confidence for particular pattern is, and accordingly based on the percentage you accept or you reject the pattern also. That is what we are doing in this case. Fine. So we'll be going ahead. So this is something that you look for, that out of like this pictorially you can define this. So mathematically, if you look for, then you can define like I is set of all items, then D is transaction database. Then when you look for association rule, A is having a strong association, B has support S. If S is the percentage of transactions in D that contains both, that means A union B. Okay, fine. And then, so that can be defined as, you can see that the support can be defined as this. Sorry, this, where actually it is actually the probability of occurrence of A and B both. Okay. Now this A can be replaced by set of items also, B can be replaced also set of items. So A and B, instead of single items, it can be a set of items as well. The formula will be same for that also. Okay. When you go for confidence, then as confidence C in D, if C is the percentage of transaction in D containing A, that also contains B. So you can see that I'm just looking for this. Mathematically, you can define that confidence of A and AB is actually probability, conditional probability given A, you are looking for B. So that will come as P A union B by PA. So this is nothing but what are the number of occurrence of A union B, and what is the probability that given this item A is already there, what is the occurrence of this also. Okay, so this we look for. So one example transactions you can see, there are transaction ID 1, 2, 3, 4. There are purchase items, say 1, 2, 3 in for first case, 1, 4 in second case, 3 in second, third case, 2, 5, 6 in fourth case. So there are 4 rows of informations are with me. Now I'm fixing support as 50% and confidence as 50%. Then we can have such rules. Like I can have rules like 1 is strongly associated with 3 with 50% support and 66% confidence. Always remember one thing, that association from 1 to 3 and 3 to 1 is different. So don't be confused, like vice versa may not be same. Okay. So in like you can view that in case of 1, 3, I'm getting 50% support and 66% confidence, whereas in case of 3 to 1, we are getting 50% support and 100% of confidence. That you can check easily from this. That what I'm looking for is that in first case, if I go for, in first case 1 3, if I go for, then you can see that actually I'm looking for one. So one is occurrence of one is in 3 transactions out of 4 transactions, and then this is actually you can say so there are 3 occurrence, and out of 3 occurrence you can see that 2 times 6 3 is occurring. So it is actually 2 by 3, which is nothing but 66%. Okay. Whereas in other case, if I look for 3 occurrences in 2 instances only, and in both the instances you can see that 1 is occurring. So that's why it is actually 2 by 2, it is 100%. Okay. So that actually we look for. Okay. So so when I say mining association rules, then it is a 2-step process. It is finding all frequent item sets. Then obviously all item sets satisfying minimum support we look for, and then we generate strong association rules from frequent item sets. It actually, we believe that certainly it must satisfy the minimum support and minimum confidence criteria, which may be fixed by the analyst or users. Okay. Algorithms for finding out the frequent item sets, we have many. We have algorithms like a priori, which is a very famous algorithm. Then we have some variations of a priori, because the a priori is very much useful and very much efficient when you are looking for a small set of data. But the moment you increase the data size, then it creates problem. I'll tell you why. Then we look for some variations of a priori. Then we actually apply some sampling, some partitioning techniques, some hash-based techniques, and the transaction reductions. And there are many more also. Okay. So let us go for first algorithm, that is known as a priori algorithm. It actually creates some Boolean ARs also. And what we do is that it is actually a level wise search, and obviously we produce L1, L2, which is known as frequent 1 item sets, frequent 2 item set, and so on. Okay, so you go for from 1 item set to k item set, and then we go for association rules finding with confidence. There are 2 property holds for this algorithm. First is known as a priority property, where actually what I believe that all non-empty subsets of FIs must also be frequent. That means if I say that AB is frequent item set, when I say frequent item set, that means it actually satisfy the minimum support criteria. So we in that
Excuse me,
case,
sir.
yeah.
Sir, would you please go back to the previous slide once?
Yeah. Is it okay or hello?
No, sir. Actually, I was not able to figure out like what is F1, F2, so that's why I just missed the slide. So thank you, sir.
L1, L2. This is L1 is frequented 1 item set. I'll go to one example, then it will be more clear, I think.
Okay, sir.
Okay. I'm just trying to create a platform for this particular algorithm. So what actually this property says is that if AB is frequent item set, then both A and B should be frequent item sets as well. If any one of them will not be frequent, then AB together may not be frequent as well. Okay. There is another property which says anti-monotone property, which says that if a set cannot pass a test, then all its supersets will fail the test as well. This is something, it's actually complement of the other property. This actually what it is mean is that if I say that, okay, if I say that if I say that A is not frequent, once I say that the A is not frequent, then any set which contains A will also be not frequent. That means all supersets which actually having this A as one element will not be frequent. When I say set, that means I'm talking about all the items are frequent in the data. Okay, so that is what we need. So carrying these two properties and the process, then actually this is one thing which actually through some lattice representations I can see. What I have is, you can see that there are four items A, B, C, D we have initially. Then we can move on and we can actually execute the algorithm in the several iteration. In each iterations, I'll be getting some set of frequent item sets. So when I say that in first level, these A, C, and D are frequent. When I say frequent, that means it is actually satisfying the support percentage. Whatever X percentage you fix it. Then I can move further and I found that A, C, A, D, and C, D, these are frequent as well. So it is actually also satisfying the support. Then moving forward, then I can have this also, ACD also. So in that case, what is this? Is L1, this is L2, then this is L3, and so on, depending upon the items availability and the number of items in the transaction. You keep on generating this. So this is my L4 and so on. And obviously, taking union of all these will give you the global set of frequent item set. And then those global set of items will be analyzed in terms of confidence, and then you'll be generating the session rules out of it. Okay. So up to this part, is it clear for all, or any queries you can ask me? Then I'll move to the example part. Is it clear to all?
Yes, sir.
Hello?
Yes, sir.
Okay. Then let us go for example. And this example is actually, you can see that what we are doing is, this is my initial the transaction data, say database D, and then I'm just applying the a priori algorithm. So what we do is that we try to find out the first candidate set is this, where actually you can see that I'm just talking about the frequency of item 1, 2, 3, 4, 5, and this is 2, 3, 3, 2, 1, 3. Say I'm fixing support as 50%. So once if I fix this support as 50%, then you know that more than two or more than two occurrence will be satisfying this 50%, because there are 4 transactions only. So only 4 is having infrequent in this case, whereas 1, 2, 3, and 5 are becoming frequent in our case. So then this is my L1, which 1, 2, 3, 5. So this is how L1 can be generated. Now I'm moving forward for the next iteration, where actually I'll be generating the L2. So what I'll do is that I'll just make a combination of these single items into a set of 2 items, all combinations. So I'm
Sir,
having this.
I have one doubt. Sir, like you have taken 1 and 2, and then for if we take 2 and 1, will it be different, or will we treat it same?
At this stage, we this is not required to be done.
Okay.
At this stage, one combination is enough. Okay.
Okay.
So I'm just taking 1, 2, 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. See, this is reverse combination is one like only required when you look for the final rules you are looking for. Like if I have to check this 1 2, then I can check this for association of 1 with 2 and 2 with 1 with confidence, what confidence you are getting, then it will be useful. Okay, so right now I'm just looking for frequencies,
Okay.
support only. Okay, so even if you change to 1, the support will be same, because this is something talking about the occurrence of this 1 2 in this transaction database. Fine.
So, can you just please explain it again, like how we came out with L1 again with example? I was not able
Okay.
to get it clearly.
Okay. See, just see what is happening out here is you have like all distinct items you can list in this particular table. Okay. So I have listed that the list of the distinct items are 1, 2, 3, 4, 5. I think 1, 2, 3, 4, 5 only items are there. Okay, fine. Now, one has the occurrence of 2. That means you can see that one is occurring in one transaction and occurring in another transaction. So the frequency of 1 is 2. Whereas in case of 2, you can see that 2, 2, 2. So there are 3 occurrences. So I am fixing as 3. So similarly for 3, 4 and 5, I have these frequencies. Since I have fixed 50% at support, that means one item should appear in 2 transactions or more than 2 transactions to satisfy this support. Because there are 4 transactions, then having support more than 50 or 50, you require the items should appear in more, at least in 2 or more transactions, isn't it? So in this case, this is not having the frequency which is required, so I'm ignoring it, and then I'm moving forward. And this is referred as C1. This C is actually candidates, we call it. So this is C1, and now out of C1, I'll be generating L1 by ignoring these infrequent items. Okay, so we have 1, 2, 3, 5, and this becomes my L1. That is first level frequent item set. Now, moving forward, I'll be going for the all possible combination of L1 items. Then I'll be getting this set of frequencies, and then I'll be again checking the database. In each iteration, you need to check it. That what is the occurrence of 1, 2 together? So I found 1. What is the occurrence of 1, 3 together? So I found 2. That you can see that 1 and 3 in this case and 1 and 3 in this case. So I am getting 2. So once I get this, then this, then this, then this, and this. Now still I am fixing the support as 50%. So this will be ignored and this will be ignored, and now your L2 will be this. So this is 1 3 2 3 2 5 and 3 5, and this actually having frequencies. Okay. So the next level of frequent item sets are having these combinations. Now I'm moving to the third iterations, where actually I'm looking for combination of I'll be creating combination of 3 item set. Okay, so I'll be going for I can combine these 2, then these 2, then you can combine and you can create these. So once you do that, then suddenly I can create 1 3 1 2 3, then 1 3 5, then 2 3 5, then 1 3 5 also. So 1 2 5 also. So all these combinations you can generate, which will actually be because due to the non-availability of this space, I am just specifying only 2 3 5. You can see that 2 3 5 is occurring in 1 and 2, so twice it is occurring. So it is actually my third level of frequent item set. Since I have only one item list is figured out in L3, so there is no need to go further, because we cannot generate any the combination of 4 item sets for the next level of frequent item set generation. So there is no possibility of L4 in this case. So we stop here. That is, algorithm is actually stopping out here. Now what you have is, you have L1, you have L2, and you have L3. Take the union of L1, L2, and L3. So that actually what is happening in this case is that it actually generates L, which is nothing but L1 union L2 union L3. This is what happens. Okay. So in this case, what will happen? That I can say that 1, 2, 3, 5, then 1, 3, sorry, then 2, 3, and so on. And last will be 2, 3, 5. So this is your frequent item set L, which is coming from nothing but the iteration based L1, L2, L3. So so in the previous slides, you asked, so L1 is nothing but L1 union L2 union Lk. This K may vary depending upon your data and domain. Okay, so this is what the first process is over. Now you have frequent item set. Now certainly the single items may not be having associations, so we ignore it. Now we focus on these combinations. So out of you can say that out of 1 3, I can have association of 1 3, and I can have association of 3 1 also. Out of 2 3 5, this is my frequent item sets. I can have 2 3 5 also. I can have 2 3 5 also. So I can, and certainly the confidence will be different for each of the cases. So you can fix the confidence. Say if I fix the confidence as 70%, then all the association rules which actually having 70% or more will be accepted as strong association rules in our case. So for that we do it. Certainly you can see that candidate generations where actually you go for this, and this is just a mathematical notation for all whatever you have done it. This is same as which you can move on. This is pseudocode for that. This I'll discuss just right now. So when I say that how to get the session rules from this FIs, then for each FIL, that means you can see that this is L. This L could be this L could be your 2 3 5 also. This L could be your 2 3 also. That all items which is appearing in the set L could be your L, small l. Okay, can generate all non-empty subsets of L. Okay, so how? For each non-empty subsets of S of L, output the rule as S having a strong association with L minus S if this holds. So what we are doing is very simple. Say your L is 2 3 5. Now I'm looking for association with this 2 3 5. Okay, so now this 2 3 becomes your S, and this 5 is nothing but L minus S. Okay, so I'm looking for this association. So this comes. So how to get it? Then obviously you look for support count of L, and then divided by support count of S should always be greater than or equals to the minimum confidence. Say if I say 70%, that means I'm out of 4 transactions, 70% you have to find out. So it requires, I think in case of 3 transactions, it will give you 66%, no, 75%. So you require 3 or more transaction appearance to have this 70%. Now you can check whether 2 3 having association strong association with 5 or not. I can check with the data. you can see that, let me first erase this. Okay, so what you have is 2, 3. See that 2, 3 is occurring here, 2, 3 is occurring here. Okay, this is there. So there are in 2 transactions it is occurring, so 50% support is there. Now the question is, at how many times this 5 is occurring? So you can see that 5 is occurring here also, here also. That means out of 2 occurrence of 2, 3, in both the occurrence 5 is occurring. That means this particular association rule is having 100% confidence. Okay, that is what we mean it. Okay, so it is acceptable. In some cases it may not be, like suppose it's in some cases it is below 70%, you can discard. So you have to scan, you have to investigate all the frequent item sets for such association rules, and then depending upon confidence level you have fixed, you will accept the association rules and you will reject the association rules. And that is the process which we follow it. Okay, any doubt you can ask me right now. Fine.
Sir, I had a doubt about the transactions database. Like we are creating the database according to the transaction IDs. So
Yeah.
suppose a customer is buying frequently, like in 1 month he's purchasing 5 times. So each time a different transaction ID is being created for it.
Yeah.
So
See, reason is very simple. That certainly it is very hard to identify that the same customer is actually having 5 visits in a day, because normally in that case you have to actually feed the name or address or something like this. Okay, which
yes.
we are not doing. We are just processing it in terms of basket only. A basket comes to the cash count or billing counter, and it will be assigned one transaction ID, and the list of items will be there. Okay. Next.
Okay.
As
Okay.
far as your concern is that can we track the customer or not? So in that case, you have to have the customer must be a member of your retail market. Then only you can track that.
It's a like loyalty scheme.
Yeah, loyalty scheme and others. And obviously, that may not hold for all the customers. Very few customers are ready to share their personal information. Okay, and certainly, retail market cannot pressurize for that also. So that is also. There are a few more things, like you can see that what we are actually dealing here is that I'm just tagging only that a customer is going for bread, butter, or say TV, but I'm nowhere mentioning that how many bread, how many butter, or how many uh,
Yes, and
shirts.
quantity is
Yeah,
also not.
so quantity I'm not specifying right now. So this is first level of SSM rules we are looking for. We are not talking about the quantity we look for. Certainly, the moment I have to include this part also, I need to alter my algorithm also, which is actually, you can say, what we call it as utility based association rule mining. Okay. Uh, there are several papers on this, and people have worked on it also, and you can work also in that utility based mining as well. Okay, so I'll just give you some idea in that case later on, and certainly there are some I can provide you some suggestions for reading, and you can go through it. I think we have a very short span to cover all such topics. Okay. Now, there is something which is very important in this case, that we actually the a priori actually possess two properties, say anti-monotone property and a priority property and all. So I can make use of that property in between its iterations, and that is known as pruning steps. Okay. What we do is that we prune those candidate items with all of whose subsets are not frequent. I think for example, I can tell you that suppose you get L3 as this, that you get that L3 as this, that these are the items which are frequent. Okay, so you got L3. Now, moving to L4, then obviously there will be a self-joining of L3. Then you will be generating some, say, A, B, C, D or A, C, D, E. Okay, fine. Out of ABC and ABD. ABC is there, ABD is there, and then out of ACD and ACE, I can generate this also. These two are the element of L4. Now, as per the property, if I apply the property in here, then obviously ACD is removed. Reason is very simple. That property says that all subsets of this should also be frequent. But you can easily identify in this case that this is not present in this, whereas this is subset of this. So since this is subset of this which is not frequent, certainly I can discard this then and there itself rather than going to investigate the database for checking this frequency. It actually reduces the complexity of the algorithm also. It also reduces the number of search which you perform on the transaction database. Always remember, though I think you people are actually from management, in computer science, it is always we look for complexity of the algorithm. That means we look for time or storage, all these complexities. Okay, time is obviously I can estimate that rather than I can have a direct estimate for this. This estimation is done in terms of the number of scans, okay, number of iterations, and many more. Obviously, if you are doing some programming, then what number of variables, what number of functions, and what so on you have used. So certainly I'm not going in detail in that because I think that may not be appropriate for you. What actually you need to understand that number of scans means, you know that say your transactional database is of 100 GB, okay, and your RAM availability is say 10 GB. Okay, fine. Obviously, any algorithm which executes is actually using this RAM. So algorithm execution may require 10 number of scans to have this 100 GB of data, because 100 upon 10 will give you 10. That means at one time it will access 10 GB of data, then algorithm will be executed, then it will be write back, then another 10, then executed, then write back. So 10 times 10 number of scans is required to execute this a priori algorithm on the 100 GB of data. So we always wish that this number of scans should be less. And obviously not only scans, but we do search also, because the moment I say what is the frequency of ABD, I am searching each of the rows for this ABD frequency. So if I can remove by virtue of the property, then at least I have reduced this search in this process, and that actually reduce the complexity as well. Though it looks like one, but it is not one. When you are working on a large data, large number of items, then it could be significant in terms of efficiency. Okay, so that we do it. So obviously, if I'll go for C4 of these two, then only ABCD will be the part of the C4, because this subsets of this, all subsets are present in this, whereas in this case, all subsets are not present. Okay, fine.
So for this checking of subsets, we have to do it manually, or is there a method?
Actually, you cannot do it manually.
Yes,
Certainly,
yes.
for this example, you can check it manually. but normally we do programming for this.
Okay.
Okay. So it is actually we like either you can do it with program, or there are some tools where actually this a priori is available, where actually you can feed the data, you can fix up all the parameters, you can fix up your support and confidence, and then that tool will actually execute the entire iterations, and then it will provide you some set of rules out of it. Okay.
Okay.
So this can't be manually. See, in today's world, where you are actually, let me visualize the intensity of the problem. You know what? How many? What are the number of items the Big Bazaar is dealing in today? If you talk about entire India,
So in terms of variety, I think
in
might
terms
cross,
of distinct item, I'm talking.
yeah, distinct items. So maybe thousands and maybe lakhs. I'm not sure.
Yeah. So that is the thing, is that we actually think that it is very easy, or it looks very easy, but you know that it is something around 1.7 lakh distinct item Big Bazaar dealing it. So obviously all the items may not be present in your place, but if you look the span of the Big Bazaar throughout India, that it deals with more than 1.7 lakh of items. Just talk about that. Means when you talk about transaction data, then the next column is having such amount of distinct items. Okay, and just if you look on the customer visit in Big Bazaar, certainly it is reduced during this corona, but before that it was huge. So just analyzing a week data or a month data is itself is a big task. Okay, so the amount of the work or amount of analysis you actually looking for is not easy anyway. So you require a system or environment where actually everything should be all the components should be there, like storage, the processing units, and a particular like the efficient or decent RAM size should be there. Obviously, programming paradigms, platforms, all these is required, and not only these, but efficient person is also required. There is a requirement of a skilled person, like you management graduates can do that. The graduates of computer science or IT can do that. So this cannot be done by any man. That this cannot be like this cannot be done like what people are using it, like anybody can book a ticket in railway IRCTC. The moment I talk about the analysis of the IRCTC data, it cannot be done by the window people, because those people are actually having just carrying a elementary knowledge of manipulations. So in that case, you require some software engineers, business analyst, or system analyst sort of things. So that is the requirement. Okay, is that fine?
Yes, sir.
Okay, so I'm just giving a break for 5 minutes right here, and then we'll come back. Okay.